The plant and equipment used in an enterprise have a life cycle. It starts with the recognition of an opportunity, then progresses to feasibility and approval. If the idea is found worthwhile, a full design is developed, plant and machinery are purchased, installed, and put into operation. The vast majority of the life cycle is the operation phase, and this continues until the plant and equipment are eventually decommissioned and disposed of. A business is started in the expectation that the investment made to get into operation will return a profit within a specified time. The profit is only generated during the operating phase of the life cycle. The more profitable the operation, the sooner the investment is returned, and the sooner an unencumbered income stream is created. If we want to maximize operating profit, we must keep the operation performing at the throughput approved when the investment decision was made, while having costs no greater than those expected. One of those costs is the repairs and maintenance of the plant and equipment. The operating costs committed chart tells us that 70% of operating costs are set during this early stage of specifying the project. It's clear that in this very short period of time, when the blood rushes to people's heads, a great level of control over what they decide to do is needed. Detailed design and engineering. Detailed design and engineering. Design quality management system. Engineering standards/guidelines. Doctor/daft costing. FMEA/RSIM. Life cycle cost analysis. Reliability engineering. Safety and hazard analysis. Electrical system integrity/safety. Maintainability. Risk analysis. Value stream improvement. We know from the nuclear industry report that 35% of plant and equipment problems will be generated at this stage of the life cycle. The operating risks are reduced when operations and maintenance are integrated with the designers, and their long-term needs allow the design to be optimized. Once the feasibility and basic engineering studies has been worked upon, the next stage in equipment life cycle. Procurement and supply. It contains activities to as following. OEM quality system audit. Engineering standards. Workshop testing. Storeroom management for reliability. This is the stage where we get defects coming into our business from the original equipment manufacturer, OEM. If they are no better than 2.5 to 3 Sigma operators, you will get their quality problems to fix at some stage in the life of your plant. Once the material of construction activities are over, the next phase is construction and commissioning. Engineering standards. 3T precision installation procedures. Installation quality audits. Rotating equipment integrity. Project planning. Shutdown planning. Pre-commission/commissioning plan. Occupational health and safety plan. Contractor management. This is a critical period. All the best laid plans will come unglued at this stage if your equipment is installed distorted out of shape. A huge number of defects will be put onto your operation at this stage if your precautions are inadequate. Equipment installation must be done precisely and machines proven to be installed within specification. After installation and commissioning, the next is the most active part of asset life cycle. This is plant and equipment operation. Integrated quality management system. 3T operating procedures. 3T maintenance procedures. Precision maintenance. Maintenance planning and scheduling. Shutdown planning. Occupational health and safety. Emergency/disaster management. Lean waste reduction principles. TPM/operator watchkeeping. 5S workplace discipline. Value stream analysis. Rotating equipment integrity. Lubrication/wear particle management. Predictive/condition monitoring. Preventive maintenance. Opportunity maintenance. Energy optimization. Training/refresher training. Supply chain management. RCFA/Six Sigma DMAIC. HACCP. For the entire operating life of your plant and equipment, you want high plant reliability and availability. You will need to adopt excellent operating and maintenance practices. The human error rate table makes it clear that we humans make mistakes. But we make far fewer mistakes when our processes and practices become simple and routine. If we want to control the risk in human-dependent processes, it sounds like we will need ACE 3T procedures for all operations and maintenance work. The next and last phase is decommissioning and disposal. This part of the life cycle is now more important than ever. The impact of a contaminated environment will have dire consequences on our future generations. There will be high costs for treating waste and rectifying environmental damage. There are legal and ethical requirements to meet. To manage this risk, prevention and containment needs to be designed into the plant and equipment. The consequences of any accidents will be managed through operating and emergency procedures. Each step in the life cycle consists of processes and people working within systems. Evidence is clear that about 70% of equipment failures are rooted in business process and human error. Not only does failure happen during operation, but it also happens during feasibility, approval, design, procurement, construction, and commissioning. Failure in the project steps can be represented as being similar in effect to failure in operation. The components of the project systems fail, often unknowingly, and produce defects that are built into the design. The defects await a suitable trigger of circumstances and produce an operating failure. It is important to realize that operating costs can only be changed and removed during the design and project phase of the life cycle. Once plant and equipment is in place, all its associated requirements must be met. Those necessary costs cannot be lowered without increasing the risk of failure by reducing the item's reliability, with subsequent poor effects on production output. The maintenance planner can do nothing to change what happened during the project phase. It is all history by the time they work in the business. But they can change the project decisions to be made in future if they capture good, sound records of the performance and costs of the production equipment used in their operation. With believable evidence of equipment performance provided by the maintenance planner, future project designers will make better decisions in designing and selecting future operating plant. This figure shows when plant operating costs are committed. It indicates that up to 95% of operating costs are predicated or set in place during the capital phase. By the time a plant goes into operation, there is little that the people operating and maintaining the plant can do to change operating costs. During the operating phase of the life cycle, the focus is to minimize operating costs to the very lowest levels achievable with their plant and equipment. The maintenance planner contributes to this least cost of operation goal by making sure people and resources are minimized and used wisely for the greatest benefit of the enterprise. Hence why the primary purpose, to gain greater work utilization from the rest of the maintenance mechanics, is so important. The plant and equipment used in an enterprise have a life cycle. It starts with the recognition of an opportunity, then progresses to feasibility and approval. If the idea is found worthwhile, a full design is developed, plant and machinery are purchased, installed, and put into operation. The vast majority of the life cycle is the operation phase, and this continues until the plant and equipment are eventually decommissioned and disposed of. A business is started in the expectation that the investment made to get into operation will return a profit within a specified time. The profit is only generated during the operating phase of the life cycle. The more profitable the operation, the sooner the investment is returned and the sooner an unencumbered income stream is created. If we want to maximize operating profit, we must keep the operation performing at the throughput approved when the investment decision was made, while having costs no greater than those expected. One of those costs is the repairs and maintenance of the plant and equipment. Maintenance planning is a risk management strategy that comes from the wide range of operating and maintenance strategies available to organizations. The diagram shows a means of selecting appropriate project, maintenance, and operating strategies matched to the size of risk carried by a business. The methodology is known as the Optimized Operating Profit Method. It uses the more than 60 daft costs that could happen from a failure to determine the true cost of business risk, and then matches risk control practices to the risk a company is willing to carry.